Hello everyone, welcome to my channel IGCSE&GCE MATHS SCHOOL. This channel presents videos to you to improve your knowledge of mathematics to pass examinations, tests, IGCSE, Edexcel, Cambridge O-Level, GCSE, SAT, CAT, PSAT, NMSQT, and such other parallel examinations, right? Okay, this channel posts videos daily to improve your knowledge of mathematics to pass your examinations with flying colors. So therefore, stay with us continuously and subscribe to the channel and like, share and comment on the videos, right? Okay, now we are straight away going to our video today. Today's video is on how to find the upper bounds and lower bounds and the range of values when the corrected value has been given to some degree of some significant figures, where the degree of accuracy is significant figures. Here before we have posted two more videos, previous videos on how to find upper bound and lower bound in cases where the numbers have been corrected to whole digits, like nearest unit, nearest 10, nearest 100, nearest 1000, and where the numbers have been corrected to decimal places. The correct to first decimal places, correct to two decimal places, and correct to 3 decimal places. Now today's video is on how to find the upper bound and lower bound and the range of values that can be rounded to the given corrected value, the given degree of accuracy, when the degree of accuracy has been given in significant figures, right? Okay, let's go to the video straight away. Then when the significant, we say there is a number corrected to, let's say 2 significant, let's say now 56, corrected value is 56, corrected to 2 significant figures, in that instance, you know, to find the upper bound and lower bound, you have to get the degree of accuracy. Then the significant figure is not a degree of accuracy actually. Therefore, we have to find the degree of accuracy to be used in the upper bound and lower bound formula to find the upper bound and lower bound when the corrected value has been given to some significant figures. Therefore, when the corrected value has been given to some significant figures, to find the upper bound, lower bound, and the range of values that can be rounded to the given significant figure, range of actual values that can be rounded to the given corrected value, the given significant figure. Then the significant figure itself is not a degree of accuracy. Therefore, we have to find the degree of accuracy which is to be used in the lower bound and upper bound formula to find the upper bound and lower bound and the range of values. So let's see now first of all that the first challenge when you are given the corrected value to some significant figures is to find the degree of accuracy to be used in the upper bound and lower bound formula and range. So that's what we are doing first of all. This is the way to find the degree of accuracy when the numbers have been given correct to some significant figures. Then the thing is, now you have to find the degree of accuracy with reference to the place value of the particular significant figure. For example, the number has been corrected to 2 significant figures, then you have to find the place value of the second significant figure. If the number has been given correct to 1 significant figure, you have to find the place value of the first significant figure. If the number has been given to 3 significant figures, you have to find the place value of the third significant figure. So accordingly, the place value of the significant figure is the degree of accuracy. For example, now take example like this, say 256. 256, let's say this is correct to 3s. Let's say this is a value, this is the corrected value to 3 significant figures. Then what you do here, the degree of accuracy given in degree of accuracy third significant figure. So now we have to go to the place value of the third significant figure. I told you the third significant figures are counted from the left side. Then what is the significant figure? That is any digit in the number except the preceding zeros. Intervening zeros are significant figures, but preceding zeros are not significant figures. Now preceding zeros are the leftmost zeros, but there are no leftmost zeros. The leftmost digit is 2, that is a non-zero digits. Therefore, first significant figure is this. Then first significant figure, first one, second one, third. This is the third significant figure. Therefore, now as the number has been corrected to 3 significant, you go to the third significant figure and look at the place value of the third significant figure. What is the place value of this? 6. That is units. That is units. So units, tens, hundred. These units. Therefore, in this case, to find the upper bound and lower bound of this corrected value, the degree of accuracy that you take is 1. Why? Because the third significant figure, that is the significant figure to which this has been rounded off. This has been corrected. This is the corrected number to 3 significant figures. So therefore, we go to the place value of the third significant figure. Place value of the third significant figure is units. Therefore, the degree of accuracy, therefore, units. Then when the degree of accuracy is unit, as degree of accuracy, what we put is 1. That is another one. Then take another example, 13. Let's say this is 13 corrected to, let's say, 2SF. This, we'll say this corrected to, let's say this is 50 corrected to 1 significant. Corrected to 1 significant figure. Corrected to 1 significant figure. Then corrected to 1 significant figure, as the degree of accuracy has been given in significant figures, then you go to the particular significant figure in the number. Here, 1 significant means the first significant figure. First significant figure is in this number, there are no preceding zeros. Therefore, 5 itself, the first digit from left side itself is a non-zero digit. Therefore, it's the first significant figure. There's a 5 is the first significant figure. Then, what is the place value of this 5? Place value of the unit tens. Therefore, degree of accuracy. What is used as degree of accuracy to find the lower bound, upper bound of this corrected value is 10. That is how you get it. Then next one, take another example here. Then say 200. Then correct to, I say, correct to 1 to 1 itself. Right. This one 1 itself. Right? 200. Correct to 1 itself. Then 200 is the corrected value. Corrected to 1 significant figure. Therefore, you go to first significant figure. First significant figure, you go to the place value of the first significant figure. Go to identify the first significant figure. See whether there are any preceding zeros. There are no preceding zeros. There are no preceding zeros. Therefore, first digit itself is a non-zero digit. Therefore, it is the first significant figure. The first significant figure is 2. Then go to the place value of 2. What is the place value of 2? These units, tens, hundreds. Then here the place value of the first significant figure is 100. Therefore, 100 is the degree of accuracy to be used to find the upper bound and lower bound of this corrected value. Now I think you got some understanding. So therefore, I straight away go to these examples. You know how to get the degree of accuracy to be used in the upper bound and lower bound formula. To find the upper bound and lower bound, and the range of values. When the corrected value has been given to certain number of significant figures. Now the first question 1. The question is find the upper bound, lower bound, and range of actual values of each of the following corrected values. Right. Now I have written the formula. Upper bound formula equals corrected value plus degree of accuracy over 2. Lower bound I have found corrected value minus degree of accuracy over 2. Range, this is the range formula. Range equals lower bound less than or equals actual value less than upper bound. Right. Take the first example. Then we calculate upper bound. What is the upper bound? 361. Corrected value is 361. You put it as it is. Then plus on the degree of accuracy. To find the degree of accuracy, you have to go to the place value of the particular significant figure to which it has been corrected. Now look at this one, the first one. This number has been corrected to 3 significant figures. Then therefore you have to go to the third significant figure, and to understand the place value of third significant figure and put that as the degree of accuracy. Now go to third significant figure, this one. There are no preceding zeros. The first digit on the left side of the number is a non-zero digit. Therefore that itself is the first significant figure. Then first significant figure, third significant figure, sorry, first significant figure, second significant figure, and the third significant figure is this one. Then third place value of the third significant figure is what? Units. Units, tens, hundred. There are no decimal places. Therefore units, tens, hundred. Therefore this is the third significant figure. Its place value is unit. When the place value is unit, degree of accuracy is 1. Therefore take it here, 1 divided by 2. 1 divided by 2. 1 divided by 2. Then you calculate 361 plus half. That means 361.5. Right. Next one. Lower bound. Lower bound. Again the same thing. Corrected value is the same. 361. Then minus. Then degree of accuracy over 2. Degree of accuracy over 2. What is the degree of accuracy? Again same degree of accuracy. That is what? 1. Because units. Because third significant figure is in the units place. Therefore degree of accuracy is 1 divided by 2. Then you deduct half from this 361. Then 360.5. Right. Now range. Very easy. After finding the upper bound and lower bound, then range is just to put those two into that particular format. What is that? Lower bound is 360.5 less than or equals actual value. Actual value, then less than how much? Upper bound 361.5. Right. That's done. That is the first answer. Answer for the first one. We found upper bound, lower bound in the range. Then second one. What is the second one? 3.56 correct to 3 SF. Correct to 3 significant figures. Then correct to 3 significant figures. Then upper bound we will write. Upper bound. Corrected value is this one, 3.56. Then plus degree of accuracy over 2. What is the degree of accuracy? What is the significant figure? That is third significant figure. Therefore, you have to count significant figures up to the third one on the left side. No preceding zero. Therefore, this itself is first digit on the rightmost n is non-zero digit. It's first significant figure, second significant figure, third significant figure. Third significant figure is this 6. This 6. That 6 is the second decimal place. That is the second decimal place. Then therefore you have to write this number. You have to treat as this number has been corrected to second decimal place. When the number is corrected to second decimal place, degree we wrote in the previous. Go to the previous video and I have some understanding of how to write numbers, how to find the upper bound and lower bound of the numbers corrected to decimal places. We did that. When the number has been corrected to say 2 decimal places, the degree of accuracy is 0.01. Go to that video and its description has been mentioned in its link has been mentioned in the description of this video. Therefore, go through that link and go to that video and come. Then 3.56. Then this is the third significant, which is in the second decimal place. Then you have to write. Therefore, the place value of the second decimal place is the degree of accuracy. What is the place value? 0.01. Then you get here 0.01 divided by 2, right? Equals, right? Now, what is the situation? Now you add answer will be 3.565. Then go to the next one, lower bound. Lower bound equals corrected value is this itself, that is 3.56. Then same formula, degree of accuracy over 2, that is minus 3.5 degree of corrected value minus degree of accuracy over 2, that is the formula for the lower bound. Then 3.56 the corrected value and minus 0.01 divided by 2. Then after deducting this 0.005, you are getting 3.5. 5. So that is the lower bound. Then write range straight away like this. Range equals how much? lower bound, what is the 3.555 less than or equals actual value and upper bound 3.565, right? Next one. Then third one here. Then third one, what is the number? Number is 54 to two significant figures. Then upper bound equals upper bound. Then what is the formula for upper bound? Corrected value plus degree of accuracy. 2 corrected value is 54. Then plus degree of accuracy is how much? That is how you get degree of accuracy. That is this is the second segment. You have to go to the place value in the number, which place value of that particular significant figure in the number. Place value, go to the place value of that particular significant figure in the number. Then this is second significant figure. Then go to the second significant and 1, 2, 3. This is second significant figure and look at its place value. That is again units. Units means 1 here. 1/2. Then answer will be 54.5. That's the upper bound. Then you go to the lower bound. That is corrected value minus degree of accuracy over then 54 plus 54 minus degree of accuracy over 2 half. Right. Same thing. Then 54 minus half. How much? 53.5. Right. Okay. That is the lower bound. Then range. Range equals lower bound, first of all, 53.3 less than or equals actual value less than how much? This upper bound 54.5. Very good. Right. Okay. Then go to the next one. Next example is fourth one. Fourth one again upper bound. Upper bound equals the corrected value plus degree of accuracy over 2. Then this is the corrected value, that is 6,000. This 6,000 plus degree of accuracy over 2. What is the degree of accuracy? Correct one significant figure. Now go to this number and find the place value of the first significant figure. Now look at the number on the left side. There are no preceding zeros. Therefore, the first digit itself a non-zero digit. That is the first significant figure. Therefore, this is the first significant figure. Then we go to the place value of this one. Units, hundreds. So units, tens, hundreds, thousand. This is the place value is 1,000. 1,000 over how much? 2. The answer will be 6,500. That's upper bound. Then you go to the lower bound. Lower bound will be how much? Lower bound, that is corrected value minus degree of accuracy over 2. Same degree of accuracy, 1,000 divided by 2. This is how much? Then 5,500. Then you get range. Straight away you can write range after finding the upper bound and lower bound. But in that format, then it will be lower bound will be how much? 5,500 less than or equals actual value less than upper bound 6,500. That's all. This fifth one now. Now the fifth one. Now look at fifth one. What is the corrected value? 0.003. What is that? You find the upper bound. What is upper bound? Corrected value plus degree of accuracy over 2. Then what is the correct value? 0.003. Write it as it is 0.003. Then plus degree of accuracy over 2. How to find the degree of accuracy? By referring to the place value of the particular significant figure. What is the significant figure? It's 1 first significant figure. Then find the first significant figure in this particular number. That is a decimal number. It is quite clear. Then look at in this. There are 3 preceding zeros. Preceding zeros are not significant figures, but intermediate zeros are significant figures. Now, preceding zeros are not significant figures. That is, this is not significant. This is not a significant figure. This is not a significant figure. Then this is the first significant figure. That is 3. Therefore, find the place value of that first significant figure. That is 0.001. Then 0.001 is the place value. Right? The 0.001 divided by 2. Then write what is the answer. Answer will be then 0.3335. That is the upper bound. Then go to the lower bound. Then lower bound will be how much? Then corrected value minus degree of accuracy over 2. That will be then 0.0025. Right. Okay. 0.2025. I deduct the this one 0.0005. Right. Okay. Then range we can write like this. What is range? Range we can write like this. Using that format after find upper bound and lower bound, that is 0.0 0.25 less than or equals actual values, then less than upper bound 0.0035. So that is sixth one now. Sixth question. What is sixth question? Sixth one 65.68. Then upper bound. We find the upper bound. Upper bound equals corrected value plus degree of accuracy over 2. This is the corrected value 65.8. Then plus degree of accuracy over 2. What is the degree of accuracy? You have to go to the place value of the particular significant figure. This is the significant figure is 3. This number has been corrected to third significant figure, 3 significant figures. Therefore, you have to go to the third significant and look at the place value of the third significant figure. Here, the third significant figure is first, second, third, this one, this decimal 0.1 is the corrected, the degree of accuracy, and find this now. That is 65.85. Right. Okay. That is found in lower bound. Lower bound equals again corrected value minus degree of accuracy over 2. Then equals again. Then subtract. Then you are getting how much? 65.75. Right. 65.75. Then range. Now you can find range straight away. It's very easy how to find lower bound and upper bound. Then range will be lower bound how much? 65.75 less than or equals actual value less than how much? 65.85 upper bound. Right. Okay. Now the seventh one, there's no space. I will do it somewhere here, right? Okay. Seventh one. Yes. Seventh one. Seventh one, upper bound. Upper bound, how do we find the upper bound? The corrected value, that is this one, 6 for 0.67. That is 2. Then plus degree of accuracy 2. What is the degree of accuracy here? This is degree of accuracy given in significant figures is 2 significant figures. Therefore, you go to the second significant figure and get the place value of this one. This preceding 0 is not a significant figure. Therefore, first non-zero to get 6. That is the first significant figure. Second significant figure is 7. Therefore, place value of the second significant figure is the second decimal, means degree of accuracy is 0.01. Then 0.01 over 2. Then answer will be how much? 0.675. Then you go to the lower bound. What is the lower bound? Lower bound equals corrected value minus degree of accuracy over 2. Corrected value is this itself, that's 0.67. Then minus degree of accuracy 0.01 divided by 2. That is right now equal how much? Then this one, after deducting, you get 0.665. Then you go to the range. That's very easy. After find the lower bound and upper bound, all you have to do is to substitute that lower bound and upper bound into that format of range. That is how much lower bound is 0.665 less than or equals the actual value less than upper bound how much? 0.675. Right. That's all the examples. We have done all the examples. There are 7 examples. Therefore, again and again, do those examples and practice how to find upper bound, lower bound, and the range of actual values that can be rounded to the given corrected value to the given degree of accuracy. Therefore, thank you very much for watching to the last bit of the video. Therefore, we have posted many videos previously to this channel, IGCSE and GCE Maths School. Watch those videos and try to strengthen your mathematics to pass the mathematics in the examinations that I mentioned at the beginning. With flying colors. Therefore, we post videos daily and you can gain a vast wealth of knowledge of mathematics from this channel. Therefore, stay with the channel and subscribe the channel, like, share, and comment on the videos. Thank you so very much for watching, and I will post another important video tomorrow. Until tomorrow we meet, say goodbye to you. Thank you.